Hello, it's Fred back with another FontForge tutorial. It's been quite a while since I made one of these, so I'm going to have to really knock your socks off, I suppose. That's what I hope to do. So, what we're seeing in this window here is a regular variable font using OpenType font variations. There is no format trick done here. It is a normal OpenType variable font that should work in any compliant implementation of them. Of course, a lot of tricks are being done in the font itself, but this is not a new format. If you aren't sure what nonlinear interpolation is, it is essentially the same thing as a regular variable font, except each point moves in a curve instead of in a regular line, as in linear interpolation. There are a few words for this: nonlinear interpolation, higher order interpolation. I'm choosing higher order interpolation because even though I currently only support cubic interpolation, I had quadratic working at one point. And due to how simple, well, it's not exactly simple in the software, but it would be simple now that it's done to add higher orders, 4th, 5th, 6th. I'm still thinking what the best way to do that would be, whether it would be better to in effect, take a cubic Bezier spline that's longer than one spline and take a higher order curve and attempt to approximate the lower order, try to approximate a higher order Bezier spline to a lower order but longer Bezier spline. I think that might be more intuitive for users, so I haven't implemented n order splines. But in any case, let me show you very quick how this all works. So, it is just a FontForge build script. All you do in the repository that's in the video description is just type build.sh and it will build. Now, you'll see the steps that are done here. The first thing we do is we check that the input SFD, in this case example.sfd, is sane. So what we mean by that is it has the right number of layers. I'll show you what layers are required, and that the splines are correctly numbered, etc. I'll show you all of that. And then we check the sanity of each glyph, and we build the UFO. There are 4 UFOs that we need to build, and let me open FontForge here to show you what I mean by that. So here is, for example, the letter E in the animation that we had here. So we can think of this as 4 masters. So the first master is the beginning state, which is this. So this is the kind of beginning if the variable axis is set to 0, it should look like this. And then the end state is what we want it to look at when this is 1000. So in the case of the E, we want it to go from that to that. However, if we were to do this with a normal linear interpolation, it wouldn't look good because it's impossible in a linear interpolation for the points to move in a curve like we need. So what we've done here instead is we've drawn a path for each point, including off-curve points. So what this means then is point 7 should follow the cubic Bezier spline defined by this spline. Point 8 should follow this one, point 9 this one, point 5 and point 10. Now I should note that if you're drawing a line, it's required to give it these cubic little points here, even though it's just a line. The reason for that is you can control the speed that it moves at. So that is actually something that you should do. In any case, in the 4 layer, we can see where those numbers are coming from. If we press View, Number Points, SVG, we use SVG semantics for this. So when I click Higher Order Interpolation Paths, the full name of this layer, you can see that it's based on the ones here in the 4 layer. So 0.7 should move according to this, right? And 0.5, so they aren't yet labeled in FontForge's user interface, but it's pretty easy for you to figure out what the intermediate points are named. So starting at 0, we get 0, 1, this one would be 2, that one would be 3, 4, 5, and 6. So in a cubic path, which is all that I support right now, you have 2 intermediate points between each on-curve point, and their names are by SVG semantics 5 and 6. So, given that that's the case, we can draw paths for each of them. Now, it's probably easiest to, as I did, draw them in the 4 layer. So you'll draw it along there, you'll draw it along there, there, and there, and then copy it here. And just to show you real quick how this works, I also added a tool here that can attempt to automatically name the points, so you don't need to do that yourself. For example, in the 4 layer, if we draw, let's say, a path for this 1 point to take, right? Now, obviously, we aren't going to save this, but just to show you, if we draw a path like this for this point to take, right, let's say it should take this path through the animation, and we cut this and copy it to the higher order interpolation paths layer. If we press Tools, Higher Order Interpolation, Attempt to Automatically Name Points, okay, we'll see that this point is now named 1. And that is because on the 4 layer, this point is the first point. So the point 1 should move along this path. You'll want to do that for off-curve points as well. If you don't, one of the glyphs in this font, we don't do that. Actually, 2 of them, the period and the colon. So in the period, we don't do that. We're only annotating the motion of the on-curve points. So if that is done, it is assumed that you want the off-curve points to move in tandem, basically equal to the motion. The delta should be equal to the delta of the on-curve point. So our end state here and our paths here, you can see we only have 4 of them. Now, this image right here helps us to understand how this is actually implemented in software. So what I've done here is I've generated 4 UFOs. I've generated a UFO for the A state, as I call it, so the beginning state. Then the B state is the second state that it takes. That would be this state. The C state is the third state, that would be this state. And then the D state is the fourth state. So, with those 4 states combined together in a variable font, we get this output. And the reason that that works is because if you have multiple linear axes, then they all equalize into a cubic nonlinear interpolation along a cubic spline that is defined by the 4 points. So this point, that point, that point, and that point. It's easiest to think of this actually as just a cubic spline that can be, 1 spline long, right? If we think about it, we're telling the point 3 here to start there, go here, and then go there in each master. And by using a special design space file, which I've also distributed here, we can see that this all works as expected. Let me open that design space file to show you. So you can see we're defining 3 axes, and actually the font that is generated by this design space file looks a little bit different than you may expect. So if we look at the unmangled form of the TTF, we can see how it actually works in the software. So what I mean by mangled is that essentially how this works is we add 3 axes to our TTF file, axes 1, 2, and 3, and only by playing them all together, that is, making the values equal, do we see the final animation. If we don't do that, we'll see, a glitchy output. For example, we'll see it only move in one direction and then move back in a linear fashion. Each one of these will essentially just do the same thing, the wrong thing. Even if we, for example, have 2 of them going at once, you'll see it doesn't work at all like what we expected. It's moving along on a quadratic curve now. It's not looking, at all how we expect. If we, let's say, enable the third but not the second, you'll see that it also doesn't, that it just is broken in a different way. So we need all 3 of these to always equal the same thing as we're going along, and we can do that by mangling the TTF. Now, I have distributed a script that will do that, and you may not know too much about how the font format is actually implemented, so I'll try to make this description short, but in any case, what we do is we open the TTF, and for each axis, we set the axis tag to 0001. And the same thing we do in the stat table. We also set the tag to 0001. In the names table, you'll want to change this if you want to name the axis something else. But what I've done for now is I've just made the name of each axis 1. Here's some code for that. Basically, depending on the language ID, you need to either prepend a null byte or not. But in any case, if I split to the design space file, you can see that the tags are actually named 0002 and 0003 before mangling. That's because there's a bug in the design space format. It doesn't support having multiple tags that have the same tag ID. I've already reported this upstream. So for now, we're having to do this mangling hack. And this, the reason that these are marked as hidden is so that they don't show up multiple times there. This should work in every implementation. I'm not the one that thought of this. It was showed to me by Dave Crossland of Google that this could be done. On Twitter, he showed me that, so thank you, Dave. Yeah, that's really it. I mean, I'll load the regular version again, the mangled version, so you can see, but yeah, I mean, have fun with this. The colon is a cool example. It goes from a square to a... So it goes from a square colon to a diamond colon. So a square colon is more common in sans serif fonts, and then a diamond one is more common in serif fonts. So if we look at the for layer and the end state and the paths, we can see how that's done. So it's just the same as before. Pressing view number points SVG, we can see 0, 1, 2, 3, 4, 5, 6, 7, and the paths here are set, move the 4th point like that. It's really simple to do this kind of rotation. Now, future work might be, as I stated, making it so that you can have a longer spline, and then approximating a higher order spline to your longer cubic Bezier spline. That's definitely work that I could do, but I wanted to get this out there so the community could see what I believe to be the first software implementation of this in a font editor. So you can use my scripts here, my higher interpolation tool, to automatically name the points, and then you can run my build script, and you can make your own nonlinear interpolation font. Yeah, I'm pretty sure this is the first time anybody has released this in a font editor. So, okay. Take care, everyone. I hope you learned something. If you have any questions about this implementation, check out the GitHub, open an issue, and cheers. I should mention the reason that I chose to do this in FontForge and not a more popular editor such as GlyphsApp or HLI Font Creator. It is my position that I only use open source software to make my fonts, even if doing so would make the process more difficult. I don't personally believe in using proprietary software to make a font because proprietary software goes out of fashion, the operating systems that it was made for go out of fashion, the companies that made it go bankrupt, and eventually it might be impossible or more difficult to use that software than it would otherwise be. So, given that that's the case, I try to make sure that the build process for all of my fonts can be carried out at any point in time, and the best way to do that is to use only free software in making them. So I won't be porting this to GlyphsApp, but it is open source, and if somebody were to choose to read the code and port it, there's nothing I can do about that. And I would not even, necessarily be offended.